Hello, Mindsetters. Welcome to Learn Extra Live. Of course, this is grade 12 Life Science, and this is Llewellyn. How are you?
Right in yourself, Kat.
Great, thank
Keeping
you. We're doing population ecology today.
That's it.
Awesome. Please tell us more.
We will in a few minutes.
Okay, so that's a surprise for a few minutes. You can go over to the board. So you do know that you can get hold of us on Facebook, facebook.com/learnextra, and our Twitter handle is @learnextra. So make sure you use these fields to communicate with us, guys. These fields, we are here for you all the time. So make sure that you send through the questions that you have on population ecology, any queries that you have, anything maybe your teacher might have said that you want to clarify, just anything. Just make sure that today you use this time to maybe give us your all, because I know that exams or trials, prelims, whatever you want to call them, they are extra soon. So you know that you need to be on your best for the next few weeks until they start. Over to you, Llewellyn.
Thanks, Kat. Well, let's just carry on from where we started off last week, or where we ended off last week. Now, population ecology. At the beginning, we looked at a couple of things, but we're going to go back to something that we started with, that we ended off last week, because you guys were asking me. I got a lot of questions about it. And let's go back so that we can understand it in a better way. I remember last week we had a look at population stability. How do we stabilize a population? Now, remember I said to you where we can introduce two things, or a male and a female, and they'll start growing, and we'll make a whole big population of them, or should I say a specific species and all of that. We'll make a huge population of different animals and all of that. But we need to get the animals at a good rate. So their birth rate and their death rate needs to become even. Okay. Now, the first graph that we actually had a look at last week was your growing patterns. We had a look at two graphs. The first one was your geometric graph, and the second one was your logistic graph. Okay. There they are. Let's get this yellow pen going. The two graphs, the geometric graph, and the second one was the logistic graph. Now, the geometric graph, okay, it actually fits inside the logistic graph, okay? That is the nice part about it, okay? So as long as you know the logistic one, you can actually find out a lot about the geometric one, okay? Now, sorry, I know I'm rushing through this piece, but at least we can, just a quick recap. Oof, let's get rid of this. There we go. There we go, logistic. We went a little bit too far. Geometric graph. Now, your we're going to get this right. Geometric graph patterns. It's very, very strange. They call this the J-shape graph. Okay, the J-shape graph. What actually happens is we actually start off with something nice and small. I'm going to use a different color pen so we can actually go for it. We start off. We introduce these animals or different species, right? We introduce them, and they grow extremely quickly, right? The birth rate of it is quite high. The death rate very, very low, because they don't know there's no predators for them to kill them. So what happens is they speed up quite nicely. They grow quite nicely. Now, this graph normally comes with things like bacteria. So when you're getting sick, like I am at the moment. So when you're getting sick, this is what actually happens, right, with the bacteria. Okay, so they grow nice and fast. They get this huge good curve, and they come up from almost nothing to feeling very bad. That's how you feel. So as they dividing, can you remember? It starts off with one cell. It goes through division, making it 2. The 2 go to 4. The 4 go bigger and bigger, and they just get huge. So they actually, it's almost like it's an asexual thing. If you have a look at the top, okay, logistic graph, it normally happens to a population that expands very quickly, right? It's normally an asexual thing. So they can reproduce very, very, very quickly. Okay, now, last time I brought up this, I got a lot of questions asking, what is this dotted line for, right? This dotted line just tells you where it stops, okay? So what actually happens is, you will notice in the next shape, in the next graph that we do, right, there is dotted lines between everything. Now, I've got the one and I've got the other. It's just they've put two J-shaped graphs in there, so you can actually see what happens. Now, normally what happens is it shoots up nice and high, And then, of course, we start taking our antibiotics. Now, I'm talking bacteria, so you can use antibiotics, right? So we use antibiotics. It goes nice and high, right? We use antibiotics and we kill them. So it drops quite low, quite quickly, right? It drops nice and low. And then what happens? We stop taking our antibiotics and it starts growing again, nice and high again. Then we decide, no, we're feeling too bad again. We better take our antibiotics. We take our antibiotics, and it drops down. And we decide we're actually going to listen to the doctor for once in our lives. And we're going to take all of them, and we kill them off right to the end. We're feeling great, 100%. We can do all our sport. Right. Now, that is what happens with a geometric graph. Okay, so that's quite a nice one. The next one we have a look at is your logistic graph. Okay, that normally happens when a population becomes stable. Now, this afternoon I was watching about the wolves, right? In, what's that park? Yellowstone Park overseas, right? So what they did was they came in and they killed all the wolves out, right? So the whole ecosystem, because remember, this is what we're doing, the whole ecosystem gets damaged. I mean, you take out one animal, it's like a house of cards. You take out the bottom one, they all just fall flat. Now, the problem with that is you don't just take out the wolves, you kill a lot of other animals, right? Like the beavers got affected, even though it's not part of the wolves. The beaver gets affected. Now, that there, if you take out something, something gets destroyed. It's part of the food chain and food webs and all of that things, which is also part of the section, right? But if we have a look at this, the part that gets to me with this is that they had to reintroduce this wolf population, right? So they took an alpha male and an alpha female from a different part of the world, and they brought them in, and they started reproducing. In the beginning, it was very, very slowly, right? But as soon as they started getting it, it started increasing quite quickly, and they just rapidly increased, and then after a while, they started stabilizing and becoming a nice, even rate. So let's have a look at it. This is the logistic growth graph, okay? Now, it's also called the S-shape graph. If I have a look at it, I'm actually going to increase here so I can actually show you what I mean. If we have a graph, okay, it actually looks like that, right? Can you see the S-shape roundabout? That is what it is roundabout. It's an S-shape graph, okay? The first one was a J, remember the J. The second one is an S-shape, which is quite cool. Now, if we go back, you will notice that there's 5 different regions, okay? Each region's got a specific thing. Now, I want you to remember, when we looked at the J-shaped graph, we had those dotted lines, right? Those dotted lines are going to come into play here. I'll show you exactly what I was going through there, right? So let's have a look at it again. It's your S shape, and don't forget the other one was the J shape. Okay, you can see the two different ones: the geometric graph and the S-shaped graph, which is your logistic growth. Okay, very nice. Hopefully, we're getting you guys knowing what's going on. Right, we start off. Logistic growth patterns, right? You get the first stage. Now, if I had a look at those wolves, because, you know, I love my wolves. If I have a look at the wolves, you got the first piece where the wolf was introduced. They ran around. They had to go find out where their food is. They had to find out where the water is. They had to go make a den, right? They had to mate. And then you still get the gestation period of where the puppies are being made inside and then giving birth. Now, that is the whole lag phase. That's the first part. And the nice thing is, there it is. I put it up here. Hopefully you can see it. It's quite a lag phase. It's increasing very slowly because those puppies have got to grow up and then new litters are going to be made again. So it's quite a slow process. Okay. Next one, you get the geometric graph phase or the growth phase. Now, remember I said that the geometric graph is part of this. Well, there it is. Okay, the J, as you can see, I know it's a bit stretched out so you can actually see it nicely. This is where the J comes in. Can you see the J? This is where the J comes in, which is quite important. Now remember, that is, if I have a look at it, that would be your dotted line over there. I'm trying to draw a dotted line in here, but it's very skew. Okay, so you get your dotted line. That's that dotted line on the other graph that everybody normally asks me about, right? That is where we could make or break it. That's where we get rid of bacteria. Okay, so you get your nice J-shaped graph. So what is actually happening there? Can you remember? Okay, the second phase is called your acceleration phase. Remember I said to you with the bacteria, they just shoot up nice and evenly, right? We started off feeling a little bit under the weather, and the very next day you're feeling worse, and the next day you're even feeling worse, and then you go to the doctor, right? Because we never go to the doctor when we got a bit of a sniffle. We always wait till the bitter end when we're dying, right? Which is not very clever. So what we actually need to do is go early, and then we can kill it. But in this stage, it's going up nice and strong, and it's solid, right? Then it gets to where we're going to start competing, okay? Now we're on the next phase, okay? Now we know where the food is. Now we're starting to have people fighting, right? You get the daddy coming along, the daddy wolf chasing the big males away because now they want to mate. These new big males, or should I say youngsters, are chased out of the pack so that they can go make a new pack for their own, right? So that's when you get this deceleration phase. This is where, this part here, this phase is where you actually, okay, you'll notice that the natality rate, remember what natality rate is? It's the birth rate, okay? The natality rate, or the birth rate, is still high, but the death rate is actually catching up. It's still lower than the birth rate, the death rate, of course. So the death rate is lower than the birth rate, so we'll still get a nice, even, like a climb, right? A nice slow climb so we can actually get going, right? That is what happens in the deceleration phase. Remember, this is starting to climb, then we get the deceleration phase. The next phase, yeah, the equilibrium phase. Now, let's start getting some other colors going here. Let's see if this will work. There we go. Yeah, I chose pink again. I'm going mad. Now, this equilibrium phase, this phase here, this is a nice part. This is where the birth rate and the death rate actually start becoming even. And if you have a look at it, what I've done is, I've actually, green, I like green. What I've done, sorry, you will notice that it goes down and up, and down and up and down, okay? So if you have a look at the flow, now, up means the birth, right? So that's when we start getting, like, to breeding season, and they start having youngsters and then pups, and if you have a look at the lions start having cubs and all of that. So that starts increasing quite nicely. But you're going to come to the rest of the year, right, where you are going to have some deaths. It's hard out there in the wild, right? There's not enough space for all these things. So what happens is we get a drought, or we get something like that, and it actually starts, well, I can't say a drought. Let's say it comes to, in the Serengeti, you normally it gets a bit hot and the rivers dry up and all of that, but it's not actually that bad. Right, for us, not bad. For them, it is. So their food runs away. They go to greener pastures. I like that one, okay? Greener pastures. That's yes. Nice. So they go to greener pastures, and they go have some food over there where the lions have got their territory, so they're not going to leave. Right? So we actually getting them, they're staying there, so whatever animals they can get to, they'll eat. But sometimes there's not enough food, so some are going to starve. That's nature, right? And so they die. And then it comes to all the animals coming back this side, and then we start having babies again. The conditions are favorable. You always got to remember these type of terms. Conditions favorable, right? And they start increasing again. Now, the last phase on this is the death phase. Now, the death phase actually happens when we wipe out. Now, this is what happened to the wolves, okay? This is what happened to the wolves. So right in the beginning, when wolves were put into Yellowstone Park, not by humans, by whoever put them there, right? They came up, they introduced themselves, they went up and down, they got a nice stable condition, and we get farmers. And farmers decide, no, we don't want to lose our sheep, so we're going to shoot them. So they start killing wolves. They make a nice fur coat, everything like that. They're no good, they're eating our sheep, and it's costing us a lot of money, so we'll shoot them. So what did they do? They shot them, and the last one was shot, and now we extinct in that area. Okay, so if you've noticed, they go all the way down to the bottom where there's nothing left. Okay, so that is how it starts. Where it starts, how it gets to stabilizing, how it stays stabilizing, and how they go to nothing. That is the logistic graph pattern, okay, which is quite nice. Perfect. What I've done, let me get to there. I've actually summarized this whole part, okay? So I've actually said to you, don't forget, with the fourth stage, the equilibrium stage, as I said, the mortality rate and the natality rate, they even out quite nicely. And then you get the death rate, where we actually, humans either interfere, as I said, there we go, human impact. Very important, because part of the one section that we actually do in this ecological studies is that humans impact in everything, right? We take over, we decide what's going on. The animals don't have a chance. Okay, so we do this, they have diseases, you get your, what's that flu, the bird flus and all of that. So things do die out, right? But they'll survive, okay? And then, of course, we go to the next part. These are the graphs itself. How do we find out about these two graphs, okay? If we have a look at it, how do we get them to stabilize with each other, okay? I'm going to have a look at the S-shaped graph, okay? The logistic graph. And we're going to have a look at how we can get there, or what actually happens there to make sure it's perfect. Okay, so let's have a look. We've got two factors that influence how these animals survive, okay? You've got the dependent factors and the independent factors. Now, dependent factors. Can you think of anything that is dependent, okay? What does dependent factors mean? And what do independent factors mean? What I've done here is I've put here shelter, competition, food, and water. Okay? Without space and shelter. Okay? Without space and shelter, they get restricted and they start fighting and they start killing each other, and it's not going to work. Right? Shelter, they need to be protected, otherwise they are going to get sick. Okay? That is a big thing. Competition, I've just mentioned, right? You get a big male and another big male, and the best genes are going to win. So they compete with each other, right, to see who can breed. They don't let both of them breed. Only the one will breed. The strongest gene will breed, nothing else. Okay, because the weakest gene, we don't want it. Only humans do the weakest genes. When it comes to animals, we make sure that all the animals, the strongest, will survive. That's why you get the alpha males and the big lions protecting their territories, right? Only the strongest will breed. And then, of course, food and water, right? I spoke about it earlier, where the water dries out, it gets nice and hot and windy and stuff like that, and the water dries up and they die, right? Okay? And then last one, the independent factors is nature, okay? If we have a look at it, we can't look at the climate. I mentioned climate earlier, but I'm talking about water sourcage in the climate, right? Or we suck out the water, or we do something to the water, or we pollute the water, okay? Climatic factors is summer and winter, okay? It's going to happen. You can't change it, okay? The animals are going to die. They're going to survive. They're going to do what they have to do according to the climate. That's why the wildebeest go to the greener pastures again, okay? They go there because their food and water's there, and here it's not. So we'll do the big migration so that we can actually go get there. And then, of course, natural disasters. So, like when we talk about the volcanoes exploding, right? Or we get meteorites hitting the earth. That's one of the things that they say that killed dinosaurs, right? So a natural thing, dinosaurs get killed. Why do they get killed? Big meteorite hit the earth. There we go. There's a nice little example. So all I'm looking at is natural disasters, not natural disasters, but catastrophes. You get your what do you call it? Your hurricanes and that take that actually kill the animals. Big disasters.
Tsunamis.
Tsunamis. There we go. I couldn't even think of the word. Okay, so those will kill it. But before we carry on,
let's take an ad break.
Nice.
Awesome. I'm on you today. I know. I can read your mind. Guys, we're going to take a quick ad break. There's already been a lot. So deliberate with that in your mind. And remember that you can ask us questions at any point during the show. See you after the break.